Welcome everyone to this new lesson in remote sensing techniques, but today it's more or less about the geographic information systems, also known as GIS. And in this lesson we will learn how to create shapefiles or vector data using ArcGIS, and also how to edit attributes in that and make some kind of adjustments in the presentation in arcmap. Therefore we will start with that arcmap module here. So we will create a new map with an unknown template, and as you can see, there's no georeference information or no projection defined here, because there you can see there are the unknown units. Therefore, we will first of all need a projection for the layer, and due to the fact that we are interested more or less in meters instead of degrees, we should use some kind of metric projection system, and this can be found using a UTM coordinate system, also which is based on the WGS ellipsoid. And due to the fact that we are in Morocco, and this is a special this is a certain UTM zone, we have to choose that one, and this is the UTM zone 29 north. We will add this, and as you can see here now we have defined the projection for our data we will add. Therefore I've georeferenced a geological map, and we will use that one. As you can see, here is it, and it has a different system. So looking into the properties, you can see here in the source that the system we have referenced it is GCS, which is given a unit of degrees, and but it's reprojected on the fly in ArcMap. That's a big advantage of it. So we don't have to calculate anymore, and we'll just close the toolbox to get a better overview. And also we will leave it like that maybe. There you can see there are some geological units, also break lines in the geological structure. You have some line features here, some polygonal features like these areas here. And what we will do now is we will digitize each of these units and we'll give them an attribute. Therefore, we will surely need the catalog. So we will open the catalog. You can see it here. Normally it's something like that, a Arc catalog. It's an own unit in the ArcGIS environment, and we will concentrate on the folder we are working in. So it's more or less seminar and vector data, and using the right click we can create a new file. Someone asked me why to create a new file and not new data and save it as a new file. Let me explain like this. Like, you're writing an article and you're opening Word, and you will save Word without typing anything. You're just creating the data and you will add the information afterwards. So we are creating some kind of a container where information is stored into. So we will create a new shapefile. This is the name of vector data in ArcGIS, and the name will be units. And due to the fact that we are interested in the area, or where are the areas of special geological units and geological structures, we have to store that as a polygon. And so we have the polygon, and now we are saying what is the special reference of that file. It should be the same as we can see there. So it should be UTM, which is a projected one, WGS 84, Northern Hemisphere, and we will go to the zone number 29N. So we have selected that. We'll just press OK, and as you can see, you have a tiny summary of the projection. So we will use this one, leave everything else blind or unchecked, create that, and as you can see, we have now the units.shp. This is a shapefile, and we can go into the folder, and as you can see here, this catalog is creating a shapefile, and he's concerning all the other info or other parts of the shapefile, which is the SHX file, the shapefile itself, the projection information, and the DBF file. And in the DBF, all the attributes are stored, but we will come to that in a later part. So we are now having the shapefile, which is polygonal, and we will just click and drop and give that into our working environment. So as you can see here, we can also zoom to the layer, but as you might know, we haven't digitized anything, so we haven't stored any information, so there is no extent of that shapefile. The extent, or the recent extent, was only shown by the extent of the UTM zone. So everywhere we can store that. So we'll go into the details. So we have some geological units, as you can see here. So these OS unit, I don't know what it is, so you can check in the reference of the map here and search for that. But we are not interested in the moment, so we'll go back into the detail, and we would like to digitize this area. So therefore we need an editor, and for the editor, let me check where it is. So there is no editor available here. Just click right and choose the editor. It could look, or it will look a little bit different using ArcGIS 9.3, but you probably will find out what to type in. So normally in ArcGIS 9.3, you will have the units create features, and you have to check whether it is the correct shapefile. But we will go ahead with that 10th version of arcmap. So we are having here the units, and we will create a polygon. That is fine. And you can see here there's an edit tool, but we cannot edit anything because we haven't created anything. And there's a sketch tool. And we are now interested in a straight segment. In ArcGIS 9.3, this is probably a pen, or it looks like a pen. So check the pen, and afterwards you can go ahead. You see the different type of cursor, and you can just click each vertex of the raster set. You can see that you can also have a little information about the extent of the polygon due to this shape it is creating. So we will just go ahead and make the shapefile quite good looking. It's a little bit difficult because of this grayish preview of the polygon, because we have to check the areas here. So we are nearly finished. So this is our first polygon, and it is stored nearly perfectly. If you would like to edit some things, you can just edit, or check the edit tools, double click on it, and you can see each vertex, and you can also click on the vertex and change the vertex. So you can just create like this, but it's fucked up, so we will need to recreate this one. So there's also some hints where you would like to put it. You will put it here. So, and now it's stored. So we have created our first polygon, and we will cover the basics in a moment. So we will save the edit, and you should save each edit. So we will go ahead and say, okay, we would like to digitize maybe this and this as well. Oh no, well, let me digitize this one and this one, because I have to, I would like to show you some things. So I'm digitizing now this unit and this unit. So we are nearly finished. So there we go. Now click Save Edits, click Stop Editing, and everything was working fine. So we are now looking in the attribute table. So open the attribute table. This is information stored in the DBF file. So if you are opening the DBF file in Excel or in Calc from OpenOffice, you will probably see that same information. So you have some information. There is a shape and an ID and an FID. The file is something like a feature identifier, maybe call it like this. And what we will do now is we will create two new attributes for that shapefile. So we will first go ahead and click on this one and say add field. In ArcGIS 9.3 it is more or less the options button in the lower right corner. So click on options and you will find the same. So add a field. We will now add a field which is called unit name. And this is probably more or less the name of the geological structure. So it's a text type, and the length of 50 is way too much. So we will just use this short annotation, and it's 10 should be more or less enough for that reason. So as you can see here, you have the unit name, and we will now create another field. This is the area in square kilometers. Though this is more or less a float value. Just leave it like that, so you don't have to differentiate between precision and scale. So we will use it. So we can create area square kilometers in a moment, but therefore we just have to start the editing session again. You cannot add a field in an editing session, so you have to start it again. So we'll create a unit name, and we first have to check what is the name of the unit. So this is the OS unit. We will create here and say this is OS, and this was DM-S. DM-S, copy paste, there we go. And we will create, or due to the fact that we are using a GIS environment and we always have the area information or the geographical information behind our data, we can calculate the area quite quickly because, he's knowing where the vertexes are, and he can differentiate between, and he can use triangulation to calculate this area. So we will right-click on area, and you can check the calculate geometry button here. And of course, we are interested in the area. We will use the coordinate system of the data source, and the units is measured in square kilometers. Just click OK, and there you have the square kilometers. So first unit, the bigger one, has 32 square kilometers, second one nearly 1 kilometer, third one nearly 4 square kilometers. So this is the information we have in the moment. This is quite the basics. So create a shapefile, add a field, add information to the field. Now we'll go a little bit further because we are maybe interested in a differentiation because, as you can see here, the colors are all the same, and therefore we will just add the editing session here. I would like to save the edits. Double click on units, and you can see here the symbology. So we are now changing the symbology of the features. And due to the fact that we are differentiating categories of geological units, you will click on categories and you will have unique values and just one field. The field is a value field, and this is the unit name. And we have checked this. Nothing happens because you have to add all values. So we'll click on add all values. We'll go ahead, just click OK. And now you can see you have this information against this information, and you will find the OS and DMS name of the unit in the attribute table. So go ahead, and you can also check the color scheme here. You can go with matte yellow, add a symbol, just add another line filled symbol or marker filled symbol like this one, and as you can see, there are a lot of possibilities. Maybe just go ahead with the line symbol, angle of 20 degrees. Great one. So this is the differentiation, and so you can create quite difficult and quite impressive signatures for your map, which you can therefore print in the end. So as you can see here, you can easily create a map from that. But now we have to rethink some things over, because what is about this features here? As you can see, you have a polygon, and there's a so-called, I don't have the correct English translation for that, but in German we call it island polygons, because there are just islands in other polygons. So now we will concentrate on this one, how to create a quite proper topology on that feature. So we'll go ahead, once again, editor, start editing. we will create a new feature with this tool, and I will now just click on. As you can see, you can also use the Bezier function and autocomplete function and everything like that, but we will just use this basic tool now in a moment. So this was a bad one. So we are finished now, and as you can see, we have covered the island polygons. So I'm checking this. Yes, you can see there are covered island polygons. What we will now do is we will create new ones. So go ahead. I will make this hollow and just with an outline color, which is more or less red, to see it quite properly. So we are now having the bigger one. We will create a new one inside it. And we will now choose clip. And as you can see, you have the outer line and the inner line. We will just go ahead and make this a second time. So we create a new feature here. Once again, go on editor, say clip, and preserve. So now looking onto this one, there you have the bigger one and the smaller ones inside. This is one major step towards good digitizing of features. The second step is the so-called snapping function. Because you're interested in quite good topology, you don't want to have overlapping regions or underfitting regions, like regions where no geological structure is defined, due to the fact that the map is properly made, and you have on every area you have an information about the structures beyond that. So we will go ahead and we will try to digitize this one. And as you can see, I'm going into detail now. So as you can see here, you have these vertices, and you're interested in creating vertices directly on that other vertices. So therefore you will need the snapping function. You can see it here. There's the snapping toolbar and the options. Just open the snapping toolbar. There you go. And you can say use snapping to create vertices on each other. In ArcGIS 9.3 you also have the editor snapping, and please check edit sketches and also the feature you would like to snap to. These are the both things you have to keep in mind. So we will now go ahead and say units, create a new one, and you can see here I'm getting closer to this vertex, and he's snapping the pointer to the vertex. So you can also see units edge. No, I don't want to create a new vertex on that edge, just on this vertex. Yeah, on this one, and he's following the line if you're making it properly. And so go ahead, this one. No, there's a vertex in between. As you can see here, you have to work really concentrated and that you won't miss anything. So there we go, but I think we have been a little bit too far. Yeah, maybe. So we will go ahead. We're nearly finished. So now we have created a good topology because they're directly connected to each other. And there are no missing parts in between, and there's no overlapping region. So, yeah, this is more or less what you will do with the tools. You can also make selections on that. I will show you that once. So you can use this one, and you can select the attributes. Like, let me say I will use the unit name, and we will create only a subset from OS. So it's the same as OS, and we will apply that. So you can see just this one is selected. We will create an OR function here. So this is OR. Unit name is the same as DMS. Apply. Only 3 of them are selected. So these are some basic things you can create with that. You can add different kind of fields, also hypertext formats and so on. You can label these features, like right-click label features, and then you will have the attribute given in that one name shown on the screen. So therefore you also have to check the layer properties once again, because you have to identify the text string which is used. So it's more or less the unit name, and so you can see this is now OS, DMS, and so on. So these are some tasks you can do by creating shapefiles. Please use that information, transfer that information into creating maybe some line shape files, and always think about your vertexes, because nothing sucks more than creating a vector data without keeping in mind that you will need the vertexes afterwards because of some kind of computation things and so on. Because each vertex has a different coordinate, and you can do a lot of crazy things with that coordinates in further applications. So thank you very much for watching, and have a good day. Goodbye.